Let's talk a little bit about vectors. When we think about some quantities, it makes sense to just think about them in terms of a number. With the temperature outside, maybe it's the volume inside of a container or the amount in your bank balance. Those things can be captured by a simple number, but some other quantities need a little context. If a bullet was being fired at 800 meters per second, it would make sense to know whether it's coming towards you or whether it's going away from you. Simply knowing how fast it's going isn't enough to tell you everything you need to know about what you're studying. So that's why we want to talk about this idea of a vector. So when we think about vectors, vectors have some sort of magnitude. So think of that as like speed if it's a moving object. But they also have a direction. So it matters whether you're going from point A to B or whether you're going from point B to A. So if we're going to practice that, a simple way is by doing a directed line segment. So if I have some sort of point P and I have some other point Q in space, I can draw what's called a directed line segment between P and Q. The key is to draw it directly there. Practice makes perfect. And we use the arrow to denote the fact that we're going towards that direction. So in this particular case, I would say that a vector, we write V, and we write a little arrow on it to let you know that this quantity is a vector quantity. We normally write X equals something or Y equals something, but when we do that V, it tells us that we're dealing with a vector. So V equals PQ, that directed line segment from P to Q. So that's really kind of the big important point when we deal with directed line segments. But if we want to find more information about this, notice we have a P to Q. It has a direction now, but we haven't talked about the magnitude. So how do we find the magnitude of a vector? Well, if you go back and you think about, your geometry days, and we get line segments, and we could find the length of line segments. If we're dealing in 2D space, you would have this X difference, and you would have a Y difference. And so with that X and Y difference, we can always find the distance between these 2 points. So if we want to find the magnitude or the length of this line segment, we simply have to compute the distance from point P to point Q. So if we say that PQ, and we want to do this magnitude, so these double lines are what are called magnitude. You may hear me use the terms magnitude, length, and norm, all interchangeably. Norm is a concept that you'll discuss more if you take a linear algebra course or you go into a little more advanced mathematics. So I may accidentally fall into using the term norm. It's not a topic they're going to use much in this course in terms of any kind of textbooks, but it is a very standard topic in mathematics. So if I use norm, just know I mean magnitude here. So if we want to do this in terms of if this was located at point x1, comma y1, and this was low, and P was at x1, y1, and Q was at x2, y2, then if you remember from the distance formula, the magnitude of PQ is x2 minus x1 squared plus y2 minus y1 squared, all under a square root, right? It's Pythagorean theorem. A squared plus b squared equals c squared. So c is the square root of that. All simple stuff. Stuff you probably know. You're probably thinking, oh my gosh, get to something important. So from this really wraps up the idea of directed line segments. And we're going to do some examples.